we try to make something that's related to adding a 1 to a binary string. For example, if we have a binary string like this, 0 1 1 1, and after that there are of course some bunch of ones, but this is our string and we just have to add 1 to it. And look at how actual binary works. 0 plus 1 equals to 1, 1 plus 0 equals to 1, and 1 plus 1 equals to 10, and 0 plus 0 is of course 0. So this is basic binary operations. Now once we know this, we can make a S0 state, and we can say that the moment it reads a 1, so the main purpose of S0 is to keep reading 1, keep reading 0, and just take us to this point. So every single tape is infinite, and there is of course a point where this is blank. And read a 0, keep it a 0, and go right until you find the blank. And the moment you find a blank, you go in a different state, S1. Reads a blank, keeps it a blank, and comes one step back, so we are over here. And when we are over here in this position, in S1, its job is to make all ones 0 and keep doing that and keep going left. And the moment it is done with its job, it goes to a different state. The moment it finds a 0, then it changes the state while also making that 0 a 1 and keep going left to do it with all of the zeros. So it makes all of those zeros ones. In our example, when we run the machine, it was here, and the moment it find it a 1 here, it made that 1 a 0, and it kept going left and doing the same for all of that. And the moment it find it a 0, it went to S2, our new state, and it made that 0 a 1. This one also 0, and this 0 1, and S2. So this 0 became 1 and it went to S2. After going to S2, it kept all of the ones the same, and it kept going left, and all of the zeros the same. For example, it kept all of the ones the same, and keep going left like this. Zeros are also untouched and keep going left. And the moment it sees the blank, because there will come a time when it goes all of the way here and it sees a blank, no matter how long the string is. The moment it sees a blank, you keep it a blank and go to the rightmost digit, and then you turn into S3. That's it. So your head is then on this digit, which is our answer. Of course, we already were at our answer, but we just had to keep the head on this position. That's what S2 also helps us do, to go all of the way left and at that position. Now, if you closely look, it doesn't even run the loop. If the next digit is 1, then it doesn't really run the loop. For example, we already converted a 1 to 0, and if the next digit is 1, then it keeps going the other way. And the moment it reaches the blank, it just finishes. And that's how it achieves addition, because you can see that in any way, a 0 is converted into 1 and 1 is converted into 0, and these two cases are handled together. And in that way, the moment we see it in a practical example, for example, 0 1 1 1, this becomes 0, this becomes 0, this becomes 0, this becomes 1, and everything else remains unchanged. And then the state changes and it keeps going in S2. So this 0, the moment here, it becomes 1, and it becomes a 1, and it makes all of the zeros ones. There could be another 0, it also becomes 1. And when that happens, we know that we're only left with something like this if there were more zeros. And After that, if there are a bunch of ones, it doesn't matter, they remain unchanged. And then we proceed to our final state, S3, while keeping everything else unchanged and moving our head back to the first digit of the whatever the first digit is, ignoring everything, the blank, and one step right. And in addition, we can also test that if we were to really add our string, it basically does mean the same thing, that it basically converts this. The only exception why we did all of this was because of this other situation. And for that case, we have a very good example here. We can see this is a string, and according to our machine, we can also write this string here, 0 1 0 somewhere, 0 1 0 0 1 0 1 0 1. And according to our machine, this 1 becomes 0, and the moment you find the first 0, make it a 1 and then finish. But do you know that 0 plus 1 1 plus 1 equals to 1 0? And it did added it, like even if you look at this binary itself, the next digit would be 1 0. That would be the first, that would be the next in this iteration if we just added plus 1 to it. And in that way, we realize that if there's a 1 here and there's 1 is in carry, then this 1 is dropped here and this becomes 1, because you made a 0 and then it's still there, and then you drop it here and then it becomes that second 1, and the rest remains unchanged in our machine. That's how we designed the machine, that the remaining just doesn't make a difference anymore. To make a Turing machine for any binary number that gets to get multiplied by 2. For example, if you multiply a normal binary number with a 2, what happens is that it's 1 0 actually. So 2 is 1 0 in binary. You can never multiply a decimal digit with binary digit. And what that means is that, why is it 1 0? Because always we have here 1 and 2, 4, and then 8, and then we move on like this. And the bits that are activated, for example here, this is active, it's 1. This is not what we see, so we see 2. And then we take the 2 as an answer for our, because it's equivalent to what? It's equivalent to 1 0. And when we try to multiply, now we can multiply. So basically, you just multiply any binary number with 1 0. That's what this means. That multiply 1 0 1 0, or any binary number with 1 0. That's what 2 means. And what does 4 means? 1 2. That's what 4 means, right? And this is basically 2 zeros in front. And if we did this, then there will be 3 zeros. So we know that if you do for 2, you add 1 0. If you do for 4, you add 2 zeros. If you did for 8, you will add 3 zeros. So that all the even numbers get this way. But because we don't have an odd in between a binary, there is no odd in a binary string. So there is no 3 here. In that case, we do something different. But for now, you can see 0 gets multiplied by 0. It will always yield nothing. Always, there will be nothing. And then we will have a dash, just like we do binary multiplication. And then again, 1 by 1, 1 by 0, and 1 by 1. Because always what we see is that 0, 0, 1, 0, 1. This was the answer. It's just plus 0 added to the end of it. And once you see the pattern that, oh, this is how it's working, you can just basically convert it into looking at the original answer and looking at the pattern, because every time you multiply a certain binary number with a certain digit, you will always have a certain thing. So if you, it doesn't matter if the number changes, because you're just multiplying with the same thing, you will have the same outcome. Meaning that in the rule of binary, we always add this x here, and this is how 1 0 is added in the end. So we will design a Turing machine that reads 1, starts the tape, reads 1, keeps going right, reads 0, keeps reading, reads go, and the moment it reads the hash, it changes the state. This hash. So it will be over here, and it will read ones, it will read zeros, and it will read zeros, and the moment it reads this hash, it will go to the next state. And in this next state, we want it to read a hash and write a 0 to it and move left and go to a new state. I think we can also write this in a new state. Or even if it writes a 0 here and goes left, it will write a 0 here and go left here. Here we can say read 0 or read 1, read 0 or read 1, read 0, write 0, sorry, read 0, write 0 and go, read 0, write 0 and go left. And the moment you see this, we can do in the same state situation. First, what we need to do is that we need to understand that our requirement is what? What is our requirement? Our requirement is very clear and clean. We need to design something like this. For example, let me show you, like this is our X, and a Turing machine that is separated by a hash, and this is our Y. And then of course we have a bunch of these. Afterwards, always we have this 1 2 3 4 5 6 7 equal to 1 2 3 4 5 6. Okay, and then of course we have some, and on a Turing machine, on the left and on the right, always we have infinite spaces. So our question is that X is, for example, 1 1 1 and Y is 1 1. We have to get an answer here on this side 1 1 1 1 1 6, which means 3 times 2. So X multiplied by Y basically. And to do that, what we can do is that we can design a Turing machine very easily. And to do that, the first step we can take is we can first go on a S0 and first start designing our states, and then then I will walk you through how these states are really working. So then we can make a state that goes from S1 to S2, and then we can make a state that goes from S2 to S3, and a state that goes from S3 to S4, and from S4 to S5. From S5 we have a state that goes back to S2, and then we have a state that goes from S2 to S6. And why are we doing all of this? I will get back to that in a minute. Why are we doing this? Why is it like this? And this goes back to this starting point. Then we have, of course, a self loop going on its own, which will either read a hash, and it will go left. It will read a 1, it will keep it a 1, and then it will go left. And if it reads on here, it goes on state 7. And from S0 we read, if we read a blank, then it keep it like that and stay on its own position, and then just change to S7. And from S7 we have our final accepting state, that is S8. And I will also verbally tell you what every single state is doing for now, so you can really see why are we doing and what are we doing. And in S8 this is our final state, but it comes to this state after reading a blank and also taking our tape head to the right. And on this position we read asterisk, we make it a blank. This basically is our cleaning state, to clean everything, to do this and go right. And on S5 we have a transition going on its own, that's reading 1 and going left, blank and going left. And on S4 it reads a blank, reads a 1 and goes left. And the moment it reads an X, it keeps it that and it goes right, and it just goes to S2. And on S3 it stays on its own, reads a 1 and goes right. On S4 we know how it is proceeding. S3 we already know how it's proceeding, but how is it changing to S4? It's changing the moment it reads a blank. It can keep it a blank, it can go right. And on S2 it can keep a blank and go left when it goes to S6. So it can keep the blank and go left. And on S2 we know that when it goes to S3 it reads a 1, it makes it a cross and it goes right. And when it comes to S2 it reads a hash and it keeps it a hash and then it goes right. And when it stays on its own, it reads a 1 and it goes right. And in the case of this, it reads a 1, it reads this and it goes right. And that's the complete states of our Turing machine. And we totally get now we just need to understand what each and every single state is doing for us and why, and how is it fully working. Now once we are done with designing this state, one thing I think is just left is that from S6 to S0, when it goes from here to back here, this goes to this and this goes there and this goes right. Now looking at this, I will explain you state by state what every single state is doing to us. On S0 it first reads 1, it makes it empty and it goes to S1. That's what S0 is doing. And what S1 is doing, it reads a 1 and ignores the hash and it just goes to S2. It just joins the Y, and the moment it joins the Y, it ignores everything. You can see that this S1, it ignores the 1, and the moment it reaches this hash and the pointer head is on here, let me show you with my tape here. The moment this is selected, it goes right and changes the state to S2. So in S2 we are over here, and when we are over here, S2 makes 1 of like the first Y, we are here, and it makes that 1 an X firstly, and after making an X, if you see empty or equal to, then it means no ones are left. So it will keep doing it for ones, but for now this is something that comes later. But once it does the first marking for the first X after reading 1 from here and make it empty like this, it just did this mark over there. So we read a 1, we make it empty, we went right, and we changed the state. The moment we read a 1, we had to read a 1 in S0 just so that we can make it empty. And then it went right. After that, it went to S1 state, and in S1 state, we know that we just have to go to this position. That's the job of S1, nothing else. And S2 just needs to put an X over there and change. The moment it puts an X, it changes. The moment it finds a 1, it finds a 1, it puts X, it goes right. And this one is, of course, the first one after the hash, because that's what S1 is making sure. And once that happens, in S3, it goes to S3 after doing a X. It stays there. If no matter how many ones we have, it just keeps going right. And the moment we have a blank symbol, it goes right. For example, this blank symbol, it keeps it blank. The first blank when you see, it goes right, meaning here on this position. And after being on this position, it tells us, hey, this is S4. After being on this position, he says, hey, once you see that, goes to S4. And now we are in S4. We read a blank, we make it 1. So we dropped our 1 here. And we go left, meaning here, in this position. And we enter S5. S5, no matter how many ones you see, keep going left. No matter how many blanks you see, keep going left. So, and the moment you find an X, this one, go right, one step right, of course, to the next one, this next one, go here. So the moment you read an X, go right, meaning this would be the tape head now. And once you're there, go to S2 and repeat the same process. Meaning it goes to S2 and then it reads a 1, of course, makes it an X, goes right, and does the same thing again. Goes right, makes it an X, goes right, keeps ignoring ones. The moment it sees a blank, goes right to the next blank and changes the state. The moment it sees a blank, puts the 1 there, like this will be the next blank. Keep ignoring everything. The moment he sees a blank, he puts it there in S5. And after putting a blank, putting a 1 there, keep going left. After that, after you drop the 1, you have to ignore the ones. Of course, we have ones here. You can see we have ones here. Ignore them. Ignore the box. And the moment you read the second X like this, go right and go to S2. But in this last iteration, there will be no ones left when it comes back here. It will repeat it for the last time, but when coming back, it will never see a 1 in S2. And when it never sees a S1 and it goes right, it doesn't see, and instead it sees this box. The moment it sees a box, go left. And after going left, you're supposed to be in this position. And from that, keep ignoring the hashes and keep going left. That's what S6 does. If you see empty, go left and make all X's 1s. And you're supposed to make all X's 1s. Meaning, and in this, of course, there was a very important rule that meant make X 1 and go left. So if you see an X, of course, here you are supposed, now you're supposed to see an X. Make it a 1. Now this becomes 1. This becomes 1 again. So no matter how many X you see, keep going left and making them 1s. The moment you see hash, it doesn't matter. The moment you see 1, it doesn't matter. Keep going left, keep going left, keep going left. So sees 1, sees hash, goes 1, the digit left, still left, everything's going left. The moment it sees the blank, it goes in S0, this blank, the first blank. Go one step right and go to S0. If you see a 1, then repeat the same process for the remaining two ones that we have, and it will keep repeating it. It will remove this 0 from here, sorry, this 1 from here, and then we will have 2 here the same way we had. Then it will do the same thing for this, and then we have 2 ones here, and we have total in 6 now. We have 6 ones the way we should have. But after that, the moment you read nothing, when you come back here and there's nothing anymore, you don't read a 1 anymore. And here if you go, if you read and you go right and there's nothing, then what happens is that so you read, you go here, you go right after reading this, but there's basically nothing here. There's blanks now because we just wrote a blank there. That's what this is doing. Read a 1, writes a blank, goes right. And now if we have blank here, you read a blank, you stay on the blank. So this is the first blank, I think, because you stay on the blank. If you read a blank, you stay here. This is what it means. And then you go to, if you read a blank now, after coming here, of course, you're supposed to read a blank. And the moment you read a blank, you go here. And once you go there in S7, you try to these are the rules for S7. That if you read a hash, make it blank and keep going right. If you see a 1, make it blank, keep going right. So make this blank, make this blank, make this blank, keep going right. Make all of these ones that were here, they were also made blank. And after that, the moment you see a blank, this blank was equal to, and the moment you see this final blank, what you do is that in this position, you just go one step right and you go into S8. So you will be here with our answer and everything is removed and you will be in S8. And that's how you make a Turing machine for multiplying x by y. So basically what happens is that you can see that this is a Q0 state. It reads a 0, it writes a 0, it goes right. It reads a 1, it writes a 1 and it goes, but Q0 stays on its own. The moment it sees that this blank, it writes a 0 here and it goes right. And after doing this, it stays in Q1 and until it keep reading zeros, and it keeps reading ones. For example, the moment here it keeps reading zeros and like it starts from the tape, it starts here and it keeps going right and ignores the zeros and ones. The moment this tape head comes, it changes the state to Q1 because Q0's job is just to keep bring her his hair. Q1 basically then says, okay, you are on the hash symbol, write here a 0 and come here. Here's a Q1. And Q1 stays on its own and it keeps reading zeros and ones. And it should actually, I think it's written wrong here. It should go left instead of right. So it keeps going left and ignores all of the zeros and ones. And the moment it reaches this hash symbol here, it keeps it like that and it goes to this and changes the state to Q2. And that's how you multiply a number with 2. So we can see that first what happens is that on Q0, we can change the state. On Q0, this is our tape symbol. It first reads an A, it erases it. You can also do it like this, that erases it like this and chooses the A path and moves right. So the tape head is over here now. And now we are in the Q1 state. And in Q1 state, it reads a B, it skips it, and move right. Well, what Q1 is doing is, it doesn't matter if it reads A, if it reads B, it just keeps going right. But in our case, see, it reads B, it skips it, and moves right. And the moment it says, the moment you hit the end blank, move left. This blank, move left, and stay in Q1. So it will be over here. And it changes to Q2. It reads A, it match found. So it says, oh, my match is found. Erase it, because it founded the match. Erase it. In Q2, it erases it and moves to the left. Just like this rule we have here. And moves to the tape head, moves left. Now read a B, skip it, move left. It doesn't matter what you read, keep moving left in Q3. In Q3, the moment you hit start blank, move right. This start blank. In Q3, move right. Then the tape head would be over here. And the moment that happens, go to Q0. And in Q0, if you read a B, you follow the path of B. You erase it and you choose the path of B and move right. So you erase it and you move right on this. So the tape head is here on Q4, I think, because it takes the path here of B and goes to Q4. And on Q4, you hit end blank, move left. So this is blank. You read a blank, you just go left and you change to Q5. In Q5, you hit blank word is empty, move right. So you have a rule for reading blank in Q5. The moment you read a blank, and that's what we're reading, go one step right. It's the whole word is supposedly empty. So just go to Q6 and accept it. That's what the Q5 did. It went to Q6 and accepted it. Now let's try to do the testing on a word that is AB. Let's make a tape again and let's run it here. First of all, AB on Q0 reads the A, erases it just like we did. We are in Q0, reads the A, erases it, goes right on here. On Q1, reads a B, skips it and moves right. So it goes to Q1, it keeps going right. On Q1, it hits this blank and goes one step left. So we know that it hits the last blank symbol and it needs to go left now, according to the rule in Q1. And it says that the moment you read the blank, go left. This rule we're talking about, that the moment you read a blank, go left. So it should be here. And it's still in the Q1, but it made us go to the last of the word. And the moment that happens, it changes the state to Q2. And in Q2, it says there's B, right? If you read a B, it's a mismatch. It's not the same as it started with. It's a B. So if it's a B, just like this, you can see on Q2, we have a rule that says if you read a B, make it a blank and go right, but also go to Q7, which is a non-accepting state. So we make it a blank and we go right, and then we don't accept it. It's a mismatch. And in Q7, it's a rejected state, rejected word. Then we can run the same example on ABBA, which is our even palindrome, and we can try if that also works. ABBA, for example. In Q0, we read A. For example, in Q0, we read A, we erase it, and we choose the A path. And in Q1, we go all the way to the end over here, and we go one step left in here. And in here, after erasing this A, of course, this would be the first step. We read this, and once we read this, we say that this is an A, just like we said on reading a B, skip it, move right, reading a B, skip it, move right. The moment we reach this final word, just like over here, we stop and we go to Q2. And in Q2, we say, okay, you read a match found, erase it. In Q2, we have a rule for reading A. If it's also an A, then it erases it and it goes left. And it changes the state to Q3. And in Q3, it says if you read a B, skip it, move left. If you read a B, skip it, move left. And the moment you hit the start blank, move right. Like this. So our tape head should be over here. Now we know that we have hit the start blank symbol and we move right. Now the moment you read a B, erase it and choose the B path. So we erase this and we choose the B path. This is the B path that we were talking about. And in the B path, because there is no rule for A to go somewhere except for Q1, and that's the path of A. And if it goes to Q, if it reads a B, then it will always go to Q4. And in Q4, what happens is that it reads a B, skip it, move right. And in Q4, the moment you hit the blank, go left, one step left, and go to Q5. Like over here, and now we are in Q5 state. In Q5, if you read B, it's a match. You can make it a blank and go left like this, and you can go to Q3 state. Hit start blank, move right. And here we have that it doesn't matter what A's and B's you read. The moment you read a start, we are reading a blank over here. This is where we were. Go one step right and change the state to Q0. And after changing the state to Q0, in Q0 we have a rule that says that if you read nothing, go one step right and go to Q6. This is where we would be, and we would be accepted because we know that there's nothing left in the word, and the Q6 is our accepting state, and it accepts the word. Then for an example that's not a palindrome, it's A, B, A, A. What happens is that first of all, Q0 reads the A and it erases it. Then we are in Q1. Q1 reads a B, and it skips, and the job of Q1 is to find the second last digit, just like this. This is the second last, finds the block and then the second last. This is what Q1 is doing. It goes all the way here, doesn't matter B's and A's, and one step left. Then the moment you hit it, goes to Q2, reads the A, oh, match found. So job of Q2 is the founding the match for A, and the match is found, erase it and move left and go to Q3. And in Q3, it doesn't matter what A's and B's you have, go all the way to this blank symbol and go one step right and go to Q0. And in Q0, now we will take the path of B, which says if you have a B, make it a blank and go right. And that's what it did. It made it a blank and go one step right and went to Q4. And in Q4, if you read A, skip it. If you read a B, skip it, move all the way to the right. The moment you hit the blank, move one step left to make sure that we are on the second last symbol. And once you do that, you go to Q5. See, the moment you see this blank, go one step left and go to Q5, changing state to Q5. And in Q5, if it reads a, it's not match. That's what it's reading. It's not reading a B. If it was reading a B, then of course it's a match and it goes back and then starts the loop again to Q3. But because it's not a match, it's an A, it goes to this direction. And in A, it goes to Q7, which is a rejecting state, and it does nothing. It makes it a blank, and then it's not a palindrome. It's not accepted. Let's look at another small example, just A. If it was just A, what would happen if it was just A? If it was just A, in Q0, it would read an A and erase it and go right. In Q1, it will hit the blank immediately and it will move left because we already are at the blank. So it will say, oh, if you read a blank, keep it a blank, move left and go to Q2. In Q2, there's no character left and right. So it immediately reads a blank. That's what it's reading. If you read a blank, because if you read an A, then okay, we will do this. If you read something different, then we do that. But in this case, we're not reading that, right? Then we immediately go to this and we accept it, Q6 directly, because there is nothing in the word. Now looking at another example, BA. We know that in BA it's not a palindrome. So first of all, in Q0, it will read a B and will go to the path of B into Q4. It will erase it as well. And then we will be over here. And in Q4, it goes all the way to the right and one step left. So it's just like that. And then it reads a, which is a mismatch. We expected B. In that way, in Q5, we read A, we move right, we make it a blank, and we go to Q7 following this rule. And Q7, of course, is our not accepting state. And that's how this palindrome is working. So first of all, we will be trying to read a word like this. So it's a 1 that's separated by a hash, and there's a 1. And then, of course, we will have some blanks and a blank symbols here. We can quickly switch to this. But first of all, we see that SO runs, and the job of SO is that we ignore the number of 1s and we ignore the number of 0s. Whatever you have here, you just keep going to the right until you see this until you see this hash. And then when you see this hash, you take just one step right and then you change the state to SA. So now on SA, if you see 0s, just keep going right. If you see a 1, keep that to 1 and go to SB. So if you see 1, you go to SB. But in our situation, see how what we did was that we read 1, we skipped it, we moved right until we find the hash. That's what we did exactly. And the moment we find the hash, we say, okay, read the hash, skip it, move right. That's what we exactly did. And on an SA, look at the first digit of Y. So we can say this is X and after the hash is Y. So it says look at the first digit of this. This is what this is doing. In SA, look at the first digit of Y. It is 1. So Y is not 0 yet. Move right, go to SB. And in SB, if you see a 1, then move right and go to SB. In SB, here we are in the SB. Hit N blank, move left to start subtracting 1 from Y. So it goes one step back in this rule. If you see a blank, go one step back in Y and start subtracting from y. If you see a 0, make it a 1 and go one step left. That's the logic of subtracting something from a binary number. You see you see a 0, make it a 1, and the moment you see a 1, make it a 0 and go one step left, and that's it. You have just subtracted the binary string. But in our case, we don't have a 0 to make it a 1. What we do is that in SB, we hit end blank, move left to start subtracting 1 from y, and because we didn't had any zeros, it would have keep doing as many zeros it saw until the moment it sees a 1 here, it would have changed the state to S2. But in our case, in S1, it says that subtracting from y, read 1, flip it to 0, move left. That's what I exactly said. So read 1, we read 1, make it 0, and move left. So this becomes a 0. Let me change it to a 0. And we are transiting to S2 state. And in S2 state, we can see rewind y, read hash, move left. Here, it doesn't matter how many zeros you read, it doesn't matter how many 1 you read, keep going left. The moment you see a hash, change to S3. And in S3, adding to x now. Now we're adding to x, this part. Read 1, make it a 0 and go left. So read 1, carry the 0 by writing 0 and move left. So the moment we are here, we just went one step left to the hash, which was this first position, and we saw a 1, we made it a 0 according to this rule over here. And once we did that, we had to keep doing it until we saw the first 0, and after making it a 1, we would have changed the state, because then the plus finishes. That's how you plus in a binary. And because we already did it, it hit start blank, right, carry 1 and move right and restart loop. Once you do that, you hit the blank and you make it a 1. That's where you did +1. For example, see, we see the blank symbol now. Of course, that's what we see. And the moment we see that, we kept making the 1 zeros, and after that there was a blank, and we made it a 1, and then we repeated the whole process. How do we repeat the process? This time we have a 0. So in this position, see, if you read a 0 or whatever, keep moving right, find the hash, and here it reads a 0 on the right side, makes it a 0. It reads a 1, it makes it a 1, but now it saw no ones. It only keeps reading 0, 0, 0, and when it went one step right, it didn't find it a 1. If it found it a 1, then this loop would have been started again. This would have started, but no, it didn't find it a 1. It found it a hash, a blank symbol. And because it found it a blank symbol, this will run now. It will go one step left to the blank. If it reads a 0, it will make it a blank. Let's make it a blank. If it finds a hash, it will make it a blank. Let's make it a blank. If it finds and goes one step left and changes to SF. In SF, no matter what it reads, it needs to find the blank on this side. And the moment it finds it, it goes one step right and it finishes the state here. And this is our answer. And that's how this Turing machine works. Now, we need to just understand the logic of plus, how plus works. Plus is working like this. So if you find the first 0, make it a 1 and just finish there. You already added it. But if you're in a situation where you have 1 ones and then you have 0, a bunch of ones and then you have a 0, first 0, then you first have to make all the ones 0, and the moment you find a 0, you make it a 1 and then you leave. So if 0 is just the first digit, then it's so easy to plus in it. Just make it a 1 and that's it. Don't do anything else. But in the case you start with a 1 and there are a bunch of ones, you first have to make all of those 1 zeros and the first 0 you find, you just have to make that 1, and that's it. You leave it. And for minus, it's also very simple. If it's just starting with a 1, then just make it a 0 and then leave rest. It's so easy. But if you have a bunch of zeros before it, then it gets a little bit more step. So you first make all of those zeros into ones, and the moment you find the first one after it, no matter how many zeros it, you keep making it a 1. The moment you find a first one, you make it a 0 and you leave as it is. And then you have successfully subtracted 1 from this binary. And let's try to run more questions. We might say we have a question like 1, 0, followed by a 0. And in that position, we know that this is our tape. This goes all the way to this, and it reads a hash, and it moves one step right. After it reads one step right, it's looking at the Y over here, because that's what it says here. If you see a hash, keep it a hash, move one step right, go in SA. And its job is to just take us to Y, to the first digit of Y. And in first digit of Y, what it does is that it is a 0. Y must be fully 0, so move right. So it needs to be fully 0, keep moving right. And then we have, just like I said, after all zeros, there's always a blank before and after. And move right. And in SA, it says hit blank, confirmed Y is 0. Move left and go to SF to clean up. So here it sees a blank. If it goes one step right, if it's a 0, keep going right, keep going right. 0 is reading 0, keep it a 0, keep going right. But wait a minute, I didn't saw any ones to do this rule. I saw a blank, so do this rule. And then when you see a blank, go to SF for cleaning. So what SF does is that the moment it reads a 0, it keeps it a 0. So if we are reading a blank, we had to go one step behind here, and then we change the state to SF. In SF now we are on 0, exactly on 0, and make the 0 blank and go left. And if you see a hash, make it a blank and go left and change the state to SF star. SF1, sorry, SF1, and in SF1, rewind X. If you read a 0, keep it, move left. If you read a 1, keep it, move left. So his job is to just go all the way to the left until you see a blank. And the moment you see this blank on the left side of the X, you go one step right, which should potentially be the first character of X. And after you do that, you keep it. And that's your potential answer. Because there was 0, we know that our original question was this. So plussing this with this basically should give us nothing, because this wasn't 0. So I think this is the right answer, because then it reads this hash and it goes one step right and it halts and it finishes. Now let's try and doing another example question to understand how this machine is working. We can look at the question 0 hash 1. It's a simple question. First of all, our S0 keeps reading zeros, keeps reading 1, and its job is to just take us to the first digit of Y. The moment it reads a 0, the moment it reads a hash, S0, it reads a hash, it goes right over here and it goes to SA. In SA, we see a 1, it goes one step right, it reads a 1, Y is not 0, so it moves right. Here. Reading a 1, keeping it a 1, and moves right, and changes the state to SB. In SB, it hits the end blank, move left. After moving left, it changes to this state S1. In S1, it reads a 1, change it to 0 by subtracting it. So if you read a 1, make it a 0, and go left, and go to S2. In S2, if you read a 0, keep going left. If you read a 1, keep going left. If you read a hash, go one step left and go to S3. S3 reads a 0, change it to 1. See, read a 0, change it to 1 and go left. I read a 0, I made it 1 and I went left. And once I made it 1 and I move left, I hit the blank. And the moment you hit the blank, you go to S4. And because see, this was a rule, I made the 0 1 and go left and went to this state S4. In S4 we have the rule that if you see a blank, keep it a blank and go right. We went right and we follow the same process again, because we go back to S0. And when we go to S0, it resets. It reads a 1, it keeps it a 1, and it moves right. The moment it reads a hash, it skips it and moves right to this first position of Y, what it always does. And the moment that happens, it checks if it goes to SA, and in SA it reads a 0, checks if Y is empty and move right. This is what it's checking, if it's all 0, and keep moving right. And it hits end blank and Y is confirmed to be 0. And if it's confirmed to be 0, of course, because his job is to see if Y is 0. And if Y is 0, because it keeps going 0 0 left left, and the moment it sees a blank, there is no 1 to move forward. So if there is a 1, then only we move forward. And the moment that happens, it goes down and it starts cleaning the tape. In SF, it reads a 0, it erases it and moves left. It reads a hash, it erases it and moves left. And it reads 1 or 0, doesn't matter, keep going left. The moment it reads a hash, it goes one step right and goes to our final state, which should this be the answer, our final answer, which is the correct answer, 1, because it added our string. Our original question was 0 hash 1, so of course this became 0 and this became 1, and we also cleaned the tape afterwards. Then our next question is adding 1 hash 0. In that way, we read in S0, we read a 1, we skip it, we move right, we read a hash, we skip it, we move right. And now we are in SA state. And in SA state, it checks if it's all zeros. Of course it's all zeros. And in that way, it would just simply go here and go one step left and just clean the tape, because there's of course nothing to add, just like we said, and we know the answer for this. And let's try to test this one. 1 hash 1. In that way, the tape will find this hash, go one step right to the first digit of y, and once it finds the first digit of y, if it finds the 1, then it will proceed further because there is something to add into x. And once that happens, it finds the box and goes one step left so it can be sure about the first digit of y. That's what SB is doing. And the moment it finds in S1, it reads a 1, it makes it a 0 to subtract. That's what the subtraction is working. Subtraction, it makes it a 0. This one subtracts it. And after subtracting it, it moves left, which is the hash, and changes the state to S2. In S2, it reads a hash, then it goes left into S3. And in S3, if it reads a 1, it makes it a 0. Now addition is happening. If it reads a 1, it makes it a 0. If it reads a 1, it makes it a 0. And the moment it sees there's another law in S3. The moment it sees a box, which it's of course seeing, it makes this box 1 and repeats the whole process to see if there are more. But of course we know that there will not be any 1 on y. This is why it will not follow the path of this. Instead it will follow the path of this, because it keeps reading zeros and going right until it's here. And the moment it's here, it will go on this path and clean the tape. And that's why we have this rule on S3 going that will help us in a question like this, where we have 1 hash 1. In that way, if we have to add 1 hash 1, then we know that on this side, if there is a blank, first it will do all of this, and then if there is a blank on this side, it will make that blank 1 after making all of these zeros. This is how S3 is making sure that addition is happening properly.